Plate Motion Engineering Internship, Day 10, Applying Engineering Skills. A reminder that you can access your digital resources in the lesson brief of every lesson. Even though activities are available in Amplify Lessons, you will be working in the Futura workspace. You can find the Futura workspace in your Amplify main menu. In this lesson, we apply our engineering skills to define new problems related to reducing damage due to natural disasters and consider the criteria for designing structures or objects that would help address those problems. Structure and function. Activity 1, connecting to Futura workspace. You'll read today's message. Great job, interns. However, instead of taking daily message notes, you'll take the internship exit survey. Students, open Futura workspace and read the daily message from the project director. Remember that the new message, titled Day 10, Great Job, Interns, should be at the top of the inbox. Begin working on the internship exit survey form. You will have time to finish and review your answers to this survey in the next activity. Reflecting on the internship. The internship exit survey is your final deliverable for Futura Engineering. Submit your survey once you have it completed. Students, make sure you select Submit when you are done. Futura provided this survey to find out what you think about engineering and your experience as engineering interns. Sometimes it is helpful to talk through difficult concepts to help you understand the concepts more clearly than if you were to just think about them on your own. You'll discuss the questions on the survey with a colleague. Take turns answering each question on the survey. Imagine you're talking to a new intern. Students, discuss each question on the survey. Use the engineering vocabulary such as iterative testing, design cycle, trade-offs, criteria, and optimal. Did you and your partner answer any of the questions differently? Do you have any questions? Thank you for your hard work on this internship. Let's discuss your final reflections on your internship experience and how you liked working as geohazards engineering intern. What advice would you give to future interns? What did you like or not like about the internship? What were you excited about learning in the field of geohazards engineering? Now the internship is over, and we are returning to our roles as teachers and students. Applying engineering skills. For your tsunami warning system project, the problem and the 3 criteria were defined by Futura and the World Ocean Administration. Today, you will expand your thinking about engineering, define a new problem, and come up with your own criteria to define its solution. This will give you a chance to apply some of what you learned in your internship. Your new task is to think of other problems a geohazards engineer might try to solve. You'll think of a specific type of natural disaster and then consider what structures or materials you could design to help minimize damage from that disaster. The images relate to mitigating a disaster, erosion control, a building crumbling after a disaster, and human-made levees or jetties near a body of water. Some different natural disasters are hurricanes, tornadoes, floods, earthquakes, tsunamis, avalanches, volcanic eruptions, sinkholes, or mudslides. Different regions have different climates and have different possible natural disasters. Take a moment to think of some problems that are related to different types of natural disasters and what you could design to help minimize damage from those natural disasters. You'll work in groups to think of problems to solve. Each group will have a folded envelope with some blank sheets of paper tucked inside. Students, view the solution sequence sheet and get the 3/4 page sheets and pieces of tape. Find the solution sequence sheet and tape the sides to make envelopes, and then place the blank 1/4 page sheets inside. The solution sequence overview. Review the parts of the activity. Brainstorming project ideas. Each group brainstorms project ideas by writing them on an envelope and circling the group's favorite project idea. Brainstorm criteria. Groups swap envelopes and brainstorm criteria ideas for other groups' projects. Place the criteria ideas inside the envelopes. Defining a problem. Each group receives its own envelope back filled with criteria ideas from other groups. Choose 3 criteria and define your design problem. Brainstorming project ideas, steps 1 and 2. Step 1, brainstorm 10 to 20 project ideas and record them on the outside of your envelope. Step 2, choose and circle one idea that is most interesting to your group. Write your names on the envelope and then pass your envelope to another group. Students, take about 1 minute to choose a natural disaster and then 2 minutes to brainstorm project ideas. Circle that idea. When you have circled an idea, move on to the next part of the activity. You should be thinking of a structure, building feature, or specific material, shatterproof glass, that a geohazards engineer might build for the function of minimizing damage to people or property. If you need more examples, building a better sensor to detect tsunamis, building safer building supports for earthquakes, designing a window material that can withstand hurricane winds, building a temporary, safe structure for shelter in case of a tornado, designing an inflatable backpack for skiers in case of an avalanche, building an inflatable life vest to wear in case of an imminent tsunami or flash flood. Brainstorming criteria steps 3 and 4. Step 3. Brainstorm criteria for the idea circled on the new envelope you receive. Write as many criteria as you can in one blank piece of paper. Place your paper back inside the envelope. Step 4. Pass the envelope to another group. Repeat step 3 for any new envelopes you receive. Students, take 2 or 3 minutes of each round of brainstorming. When each envelope has been to at least 2 different groups, return the envelopes to their original owners. You should now have your original envelope back with at least 2 sheets of paper listing several criteria brainstormed by other groups. When about 10 minutes remain, move on to defining a problem. Defining a problem, steps 5 through 7. Step 5, when you get your envelope back, read all the criteria your peers brainstormed. There might be some repeated ideas. Step 6, choose 3 criteria your group feels are the most important to consider for possible design solutions. Step 7, define your engineering solution. Write your idea and the criteria you selected in a project statement. Remember the example from your internship if necessary. The problem was that when tsunamis occur, people in coastal areas need to be warned to evacuate. The criteria were maximizing the warning time, minimizing false alarms, and keeping costs low. Let's hear from each group. What engineering problem and project idea did you come up with? Which 3 criteria did you choose and why? In the final minutes, present your problem and criteria. If you have time, share your reasoning behind choosing each criterion. Why is it important to determine your project's criteria before you start brainstorming solutions? You might respond, it allows you to think of as many aspects of a problem solution. It helps prioritize which parts of the solution are most important. It narrows the focus of how to solve the problem. It reminds you there isn't one easy answer. End of day 10.